Hi everyone, my name is P. Raviteja. I am working as an assistant professor in Triple Department in MLR Institute of Technology. Now I am going to discuss about Thevenin's theorem. So this Thevenin's theorem is very important and useful theorem in all network theorems. So it states that whenever there is a complicated network is there across load terminals, it can be minimized as a voltage source in series with the resistance. So that complicated network consists many number of sources and many number of passive elements are there. The total network can be minimized or substituted as a single voltage source with one series resistance. So what is this theorem? How to do this theorem? What are the steps involved in Thevenin's theorem are? First we have to give the current direction in the given circuit. Then to find the Thevenin's voltage, we have to remove the load resistance. Then after that, to find the Thevenin's resistance, short circuit the voltage source if it is a voltage source, then open circuit the current source if it is a current source, and remove the load. Find the equivalent resistance that gives the Thevenin's resistance. Now according to the statement, the total voltage and total resistances are minimized into one voltage source and in series with the resistance. That voltage source is called as Thevenin's equivalent source, voltage source, and the total resistance, minimized resistance, is called Thevenin's resistance. So see here one example. I am given one example circuit. In this, Vs is the supply voltage source, R1, R2, R3, RL are the passive elements connected in the network. So we have to find the current through the load current through the RL, that is load. So we have to follow the steps already discussed previous. We have to follow those steps. Find the equivalent voltage source and Thevenin's resistance. Now, so what are the steps what we have to follow? First one, we have to give we are already given current direction. Now when we are finding Thevenin's voltage, we have to open the load resistance. Where we have to find current, we have to open that resistance. So see here, by in this slide you can see we are removed RL and we are finding the current. After that, what Thevenin's voltage equal, V equal to I into R, we already know from the Ohm's law. So open circuit voltage VOC is equal to I into R3. What is total current? How to find the total current? Here by saying there is R2 is inactive because at the end of the R2 it is open circuit. So R2 is considered as inactive. So R1 and R3 are in series, so that we can find the current flowing through the R1 and R3, that is I equal to Vs by R1 plus R3. So that after that, when we know what is the current through R1 and R3, then after that the voltage across R3 will become the open circuit voltage. Okay, by seeing from load terminals, so we can see when we are watching from the open circuit terminals, R3 is the load, R3 the voltage across R3 will be the voltage across the load. So open circuit voltage equal to I into R3, that is I means Vs by R1 plus R3 into R3, that gives the open circuit voltage. To find the RTH or open circuit resistance or Thevenin's resistance, we have to short circuit the voltage source. If there is a current source is there, we have to open the current source. So these 2 points you must remember, and many competitive exams also these points are asking. Whenever we are finding Thevenin's voltage source and then we have to remove the load resistance. When we are finding the Thevenin's resistance, we have to remove or inactive the voltage source and current source. So what it means inactive means whenever there is a voltage source is there, we have to inactive, means we have to short circuit that voltage source. If is the current source is there, we have to open the source. So see here V1 is voltage source, so that I am short circuited that point. So then R1 R3 are become parallel and R2 is in series. While we are we are seeing from the load terminals. Then R1, R3 are in parallel and R2 is in series. The Thevenin resistance will become R2 plus R1 R3 by R1 plus R3. In this way we have to find the Thevenin resistance. After that as per statement already told that, so we have to implement total voltage sources and total network into one single voltage source in series with the single resistance. That voltage source is called Thevenin's voltage and resistance is called Thevenin's resistance. So see here in this diagram where the equivalent circuit diagram of the Thevenin's is shown here. So first, after that, at this stage, to find the load current, what we did in step 1, we have removed our RL, load resistance. So in last step, we have to find the current through the RL. So we have to add the removed resistance or removed load to the equivalent circuit of the Thevenin's theorem. Okay, here by adding RL, we have to find current through the RL. So that current is IL. So same current is flowing through the RTH. So RTH and RL are in series. So IL is equal to VTH by RTH plus RL because RTH and RL are in series. In this way we will find the load current through the load resistance by using Thevenin's theorem. In this what we did, once again I recall the steps. First we have to give the current directions. After that we have to find the open circuit voltage, that is Thevenin's voltage, by removing the load or the element where we have to find the current. Okay, so after removing the load resistance we have to find the open circuit voltage, that is step 2. After that same we have to find the Thevenin's resistance or open circuit resistance. How we have to find? By inactive the voltage source or current source. If it is a voltage source we have to short circuit. If it is a current source we have to open circuit. So after that we will get open circuit voltage and we got already the open circuit resistance, that is Thevenin's voltage and Thevenin's resistance. These we have to represent in series. That voltage Thevenin's resistance is connected in series with the Thevenin's voltage source. So in last step where we have to find which element we are removed in first step, so we have to add that element to this Thevenin's equivalent circuit, that is VTH RTH, and in series with the element which is removed earlier. So in this way we have to find load current through the load current through the load resistance by using the Thevenin's theorem. Now we will do one problem basing on the Thevenin's theorem. See here, given circuit 5 kilo ohm is the 5 kilo ohms is the load resistance. By using Thevenin's theorem we have to find the load current or current through the 5 kilo ohm resistance. Okay, here supply is 48 volts is there and resistance is 12 kilo ohms, 4 kilo ohms, 8 kilo ohms. By using step-by-step analysis of the Thevenin's theorem, we will find our load current. So in first step what we have to do? First we have to give current directions and after that we have to remove the load in which element we have to find current. So I am removed and I am given terminals A and B. So now by watching from A and B, so which is considered as load? The voltage across A and B is same as the 4 kilo ohms because 8 kilo ohms is inactive. Okay, so the voltage across the 4 kilo ohm, the voltage across the 4 kilo ohms is the voltage across the VAB. The voltage across VAB is the Thevenin's voltage. So we have to find the voltage across 4 kilo ohm by using voltage division rule. I already discussed in previous videos, voltage division rule and current division rule. Or we can find the current through the 4 kilo ohm, then we can use Ohm's law so that we can find the voltage across 4 kilo ohm. Here current through 8 kilo ohms is 0 because AB is open circuited, so that no current will flow through the 8 kilo ohm. So to find open circuit voltage, 3 milliamps is the current. By finding the current through the circuit, because how we have to find 48 ohms is the voltage source and current is flowing through 12 kilo ohms and 4 kilo ohms is same. So I is equal to V by R. 48 by 12 plus 4, 16. So 48 by 16 gives the 3 milliamps. So 3 milliamps is the current and 4 kilo ohms is the resistance, where we have to find the voltage. That voltage is 12 volts. That the voltage across 4 kilo ohm is, I already told that the voltage across 4 kilo ohms is the open circuit voltage. So that is 12 volts. That is the open circuit voltage or Thevenin's voltage. So after that, what we have to find? And third step, we have to find the Thevenin's resistance. How we have to find the Thevenin's resistance? We have to inactive the sources. What are the? If it is a voltage source, we have to short circuit. If it is a current source, we have to open circuit. So here voltage source is there, so we have to short circuit the source. So I am short circuiting the source. We have to watch the circuit from A and B. We have to stand, or we keep a eye from through the A and B terminals. Then by watching there onwards, AB onwards, we can see that 12 and 4 kilo ohms are in parallel, is series with the 8 kilo ohms. That gives the total resistance. So our Thevenin's means by open or short circuiting the sources, we have to find the equivalent resistance from the A and B terminals. So just assume we are standing at the A and B terminals. Then see the circuit. Then what will appear? 12 and 4 are in parallel and in series with the 8 kilo ohms. Whenever we are finding our Thevenin's, simply just we feel like we are standing at that point where it is open circuited. Then watch the circuit. Then you will easily get the circuit which are in parallel and which are in series. So see, from A and B terminals, 12 and 4 are in parallel and 8 ohms is series. So by finding that parallel and series combination, we will get the 11 kilo ohms. That RTH is called open circuit resistance or Thevenin's resistance. Okay. So next, so to find the, what is our aim? To find the voltage across 5 kilo ohms and current through the load resistance to draw the equivalent circuit. So already we know about the statement of the Thevenin's theorem. In it states that the total voltage source is converted into one voltage source and total elements are converted into one element. That is R Thevenin's voltage, R Thevenin's resistance and V Thevenin's voltage. V Thevenin's voltage is 12 volts, already we are calculated, and 11 kilo ohms is the Thevenin's resistance. It is connected in series with the element which is removed in our first step, that is 5 kilo ohms. Okay. Now to find the current through the RL. So RL, how to find I equal to V by R by using Ohm's law. Okay, by using Ohm's law. So 11 and 5 are in series. So I equal to V by R, 12 by 11 kilo ohms plus 5 kilo ohms. So 12 by 16 kilo ohms, it gives the 0.75 milliamps. This is the load current which is flowing through the load. To find the voltage drop across load, that gives the VL is equal to IL into RL. Means current flowing through the load and resistance across load. So that gives the load voltage across the load. In this way, we have to find the load resistance, the current through the load resistance and the voltage drop across the load resistance by using the Thevenin's theorem. So once again, I recall all the points. So to find what is Thevenin's theorem means, whenever there is a large network is there with a number of voltage sources and elements, passive elements, it can be substituted as a one single source in single voltage source in series with the series resistance, Thevenin's, that is called Thevenin's resistance. Okay, so to find this, we have to open the load resistance, we have to find V Thevenin's and R Thevenin's. After that, we have to connect the load resistance. After that, we have to find load current. So this is the Thevenin's theorem, very useful and important theorem. We can solve the many circuits by using this theorem. And okay, in next class we will discuss about the Norton's theorem and problem on that. So okay, thank you.